Hey guys, Mr. Briding here to give you the first lecture on energy transformations. We already know about gravitational potential energy. We already know about kinetic energy. The new thing, or somewhat new thing to us in this unit, is the idea of energy transformations and how often these two transform into each other. We've already talked about it, so it shouldn't be all that new to us at all. But this is going to be a little bit more deliberate in having the expectation that you understand the idea of potential and kinetic and how their sum is the total mechanical energy. And that whenever kinetic becomes gravitational, gravitational becomes kinetic, no energy is gained or lost. It stays the same. It follows the laws of thermodynamics in that energy cannot be created nor destroyed. Now we already know the calculations for gravitational potential energy. We know the different variables, mass, gravity, height, and we know kinetic energy is 1/2 of mass times velocity squared, which makes velocity a bigger player in calculating kinetic energy, where mass isn't as big of a deal because you're only using half of mass, whereas velocity is actually squared. So if you double the mass, you are doubling the kinetic energy, but if you double the velocity, you can talk, it's going to more than double the kinetic energy. All right. Then it goes over the idea of that energy is always measured in joules. And we've talked about this before, that energy is measured in joules. A joule is pretty much just saying 1 Newton meter, and 1 Newton is equal to 1 kilogram meter squared, or accelerating 1 kilogram by 1 meter per second squared. And they're just saying doing this for over 1 meter. Okay, so 1 Newton over 1 meter is 1 joule. And this is something that we learned, especially when we were learning about work. The reason why every single type of energy is measured in the joule is simply because energy transforms all the time, and every time it transforms, it's not going to be perfect. So we have to have a way of keeping track of the energy. And then it tells us to analyze the jump on Earth, comparing the energy at different positions. So it's telling you, like, whenever you're in the squat position, it might be slightly different type of energy than when you're actually, your toes have just left the ground. When your toes have just left the ground, you're probably talking that you have mostly kinetic energy. Whilst when you're in the squat, there's a new type of potential energy, the elastic potential energy, that whenever you spring up, you use the energy in your legs, and that becomes kinetic energy. Um, we're going to talk a little bit more about this idea here in a bit. I think that is it for this lecture. Other than that, I will see you guys next time. Make sure you write down any questions. Let me know.